Hi, my name is Hilmi. I am the manager of STM Think Tech. Today, because of COVID-19 pandemic, I have to send my greetings from Ankara, Turkey. I'm going to talk about multi-domain operations from system dynamics perspective during today's presentation. Here is the agenda of the presentation. First of all, I'm going to talk about STM Think Tech briefly, and then I'll deal with dynamic complexity of multi-domain operations, and I will explain the NATO resilience concept and the model that we have developed as STM Think Tech. Then I will conclude my presentation with the added values of the models that we have developed for NATO. STM is a private defense company which was founded in 1991, and government has a golden share in it. STM has actually three main pillars, which are engineering, technology, and consultancy. At the engineering and technology sides, STM has been producing products and services from naval engineering to autonomous systems, from cybersecurity to simulation models and systems and command control systems for the various defense platforms. I'm coming from the consultancy pillar of STM. At the consultancy side of the STM, we have founded STM Think Tech, which is the Turkey's first technology-based think tank in Turkey. We have founded back in 2017. We have been producing services and products both for government units and private side. And actually, the main services and products are decision support systems, business wargaming, consultancy services, and analysis and reports about the new technologies. First of all, I think we need to focus on the dynamic complexity of today's multi-domain operations problem. Multi-domain operations has an inherent complexity, which means there's a lot of interrelations among different viable systems in its complex environment. There is Navy, air, land, and space platforms, systems, and subsystems communicating each other and interrelating each other in a complex environment. So when we talk about complex environment, we talk about the sustainability of the performance, of the capacity of that complex phenomenon. So we need to understand, measure, or we need to evaluate the capacity of this complex phenomenon. Based on this complexity and complex problem solution, we as STM Think Tech have developed two resilience models for NATO. Resilience is a complex phenomenon as well, which has a lot of factors affecting each other in different ways. Within this context, I want to talk about the NATO strategic resilience concept. According to NATO concept, there is a baseline which any complex system has. There is a capacity baseline actually which a complex system has. NATO operations or NATO systems has a lot of complexity in it as well. According to the resilience concept, there is actually four main stages: preparation, absorb, recovery, and adaptation stages. According to this concept, the complex system sustains its capacity at at an acceptable level. But when there is a strategic shock, when there is an unexpected event, a big event, the capacity, the baseline capacity of the system or the operation will go down. So the system will absorb the effects of the strategic shock. Within our models, we talk about 6 different strategic shocks, from electricity blackouts to cyber attacks, martial law enforcements, big human movements, state of war, and armed conflict. We can increase the number of strategic shocks based on the problem, based on the geography, based on the system, actually. So after absorb phase, the system tries to recover itself from the effects of the strategic shock. Then the system will try to adapt itself to its previous position or to a higher position. So the system tries to keep its baseline capacity. So again, according to the NATO concept, there are 3 main resilience domains, which are continuity of government, civil support to the military, continuity of essential services, and there is also 7 baseline requirements which are combining and structuring these resilience main domains. These baseline requirements are continuity of government again, energy supplies, movement of people, food and water, mass casualties, communication and transportation. There's also some risk assessment functions for NATO when we talk about resilience concept. These risk functions are command and control, production, movement, and sustain. After looking at the strategic resilience concept, we can now look at the problem statement of NATO within the context of strategic resilience. Actually, NATO wants to learn how resilience can be applied to deliver understanding of civil environment and its impact on NATO military operations. So over here, the main aim of NATO is to develop a NATO resilience expert system. So to be able to deal with this complex problem, we used system thinking approach and we used system dynamics methodology. To be able to understand complex problems such as NATO's resilience problem, system dynamics methodology helps us a lot. So what we've done is we've produced a prototype model for one country with this country's 7 baseline requirements, 3 resilience main domains, and 4 risk assessment functions. After we produced this model, NATO wanted us to upgrade the model by adding one more country to the model, by adding an aggregation mechanism and strategic shock parameterization features to the model. Then we've created the second model, which we call it NATO Aggregated Resilience Model. So within our system dynamics modeling and simulation methodology, we first understood the problem itself. And then we made a literature review. There is a lot of researches and studies in the literature in the area of resilience. But most of them are about the resilience of natural systems. Then we made some analysis, like casualty analysis and behavioral analysis. Throughout these analyses, we have created causal loop diagrams and stock and flow diagrams to be able to understand the problem and to provide a solution to this problem. And then we produced user interfaces for both the first model and the second model itself. In our aggregated model interface, we have mainly two parts. One part is input pages, where the end users can provide their input to be able to set up the model, the simulation model. And then we have output pages. In the output pages, we have country-wise output pages and the aggregated output pages, since we have more than one country in our model. Now I'm going to talk about the input and output pages briefly. So we have two countries in our aggregated model. For each country, we have 7 baseline requirements. We provide a baseline requirement input page for the end users. So end users can insert their inputs to set up the model by using a scenario document. In these projects, we also have produced a dummy scenario document for NATO. Over here, we have 7 baseline requirement parameters for country A and for country B. When the users insert their parameter values into the model, they can also change the values of the parameters in a user-friendly feature. And the other input page is the strategic shocks input page. At the strategic shocks input page, we put 7 different shock types for both country A and for country B. The end users can define the start time for each shock for each country separately. And end users can also define the magnitudes of the shocks for each country, like minor shock, moderate shock, or strong shock, based on the potential effects of the shock. End users can also identify the absorb duration, recover duration, and adapt duration of the strategic shocks for each country. Our input page also has a weighting mechanism for prioritizing the strategic shocks for each country. So the end users can identify different weights for each strategic shock for each country. We also developed input page for aggregated resilience and risk. So we used analytic hierarchy process methodology in order to define the weights for the parameters for both resilience domains and the risk assessment functions. Over here, by using these input pages, the end users can easily identify the related weights for both resilience main domains and the risk assessment functions. In this page, the end users can also identify the importance weights of the countries as well. When we come to the output pages, we do have country-wise output pages. We can see what happens for each country for each baseline requirement, which means 7 different output graphs for each country. And then we can also see what will happen when there is a strategic shock to country A according to the resilience main domains. And the end users can also see the output graphs for risk assessment functions for each country. We also designed output pages for aggregated output graphs. So the end users can see the aggregated resilience graphs and values and aggregated risk values. So they can see their resilience capacity for both countries, which means the aggregated values of more than one country. And the last output page is the decision support system. we exclusively developed this page for especially strategic level decision makers. Over here, the flag officers or strategic level decision makers can see the situation, current situation, by the color codes. We have used green, yellow, and red color codes to be able to identify the current status of the resilience main domains and risk assessment functions at the same time. As we run the simulation, the decision maker can see what's happening both on the resilience main domain side and the risk assessment function side in a time-based manner, actually. So the end user or the strategic decision maker can easily stop the simulation and click on one of the resilience main domains or one of the risk assessment functions to be able to see the details of the values he or she sees on the screen, on the output page. So we also put the shock processes of country A and country B, which means the times that the end users have already identified for start, absorb, recovery, and adapt durations for each country. So over here in this output page, the end user can also see the simulation day. Over here in our model, we are simulating 150 days to be able to measure the resilience capacity. Again, on this page, the total risk and total resilience values of each country can be seen by both the figures, numerical figures, and the related color codes as well. During the development of these two resilience models, we have also published two articles in international journals. The first article is Dynamic Modeling for Resilience Measurement, NATO Resilience Decision Support Model, which was published in Applied Sciences in 2020, this year. And the second article is the AHP-based aggregation mechanism for resilience measurement, NATO Aggregated Resilience Decision Support Model. This was also published in this year in Entropy Journal. Now I want to conclude my presentation. We have held two different validation workshops which the end users participated. So during these validation workshops, we got the feedbacks, very valuable feedbacks about the models. So the feedbacks can be summarized as this: the models, the approach and the methodology used to develop these models provide a unique approach to be able to understand this complex resilience problem, NATO's resilience problem. This is an approach for a comprehensive and seamless resilience assessment for NATO strategic and operational level decision makers. These models can be used as tools for helping mitigate bias in the decision-making process because of the strength of system dynamics methodology. The capability of the models to increase the number of what-if scenarios to be created. By using the input pages, the end users, both at the strategic level and the operational level, can create many what-if scenarios by just changing the setup parameters, by changing the weightings, the priority values of resilience main domains, the countries, and the risk assessment functions. So there's also a lot of contribution from the models to the quality of the explanations in the area of resilience. And these models have the potential to make more dynamic and comprehensive evaluations in the area of resilience when compared to the current evaluation capabilities. So the strategic level cockpit, which is the last output page in our model, which we name as decision support page, we use the color codes that can give a clear idea at first about the overall situational picture and country-wise resilience and risk status to the strategic level decision makers. And these models have a potential to enhance the evaluation and foresight capacities of NATO's communities of interest in the areas of resilience and civil-military cooperation. And the last, the approach, methodology, and the model have a potential to understand and manage uncertainties and dynamic behaviors embedded in multi-domain operations concept as well. This concludes my presentation. Thank you very much for listening. Again, I want to send my greetings from Ankara to all of you. Thanks again.